Howdy, my name is Kayla Graybill, and this presentation is going to be an analysis of the potential and marketability of biobutanol as a biofuel. So without further hesitation, let's get right into it. So a couple of the topics we're going to be covered are on this topics page. Feel free to pause this video and take a look at that if you feel the need to. But let's get right in. First, we're going to start off with what is biofuel. And according to Britannica, biofuel is defined as any fuel that is derived from biomass, that is plant or algae material or animal waste. Since such feedstock material can be replenished readily, biofuel is considered to be a source of renewable energy, unlike fossil fuels such as petroleum, coal, and natural gas. Now, it should be considered that biofuels are not strictly defined as low carbon. These fuels still produce carbon byproducts as a result of their combustion. However, carbon cycling is the process that allows the fuel to be considered renewable. Unlike fossil fuels, which takes millions of years to form, biofuels are sourced from algae, plant, and animal products, which is offset by the carbon dioxide absorbed by the growing of said plant and algae, or is offset by the reduction of waste going to landfills in the case of animal products. There are many examples of biofuels, but today we are going to be focusing on biobutanol. Biobutanol can be derived from algae or bacteria, but also biomass such as corn, grain, etc. Biobutanol has a higher energy per unit content than methanol and ethanol, which are popular examples of biofuels, making it an optimistic source of renewable fuel in the near future. It is also important to note that biobutanol has another important characteristic associated with the growth of algae and bacteria. Algae and bacteria are especially unique in their reduction of acreage necessary to grow. With less potential farmland needed to grow substantial amounts of biomass from algae and bacteria, they create a huge benefit of reduced space, allowing for the saved acreage to go to foliage and/or farmland, further reducing their carbon footprint. Now, the production of biobutanol, there are two main ways in which bio-based chemicals can be obtained from biomass feedstocks. Approach number one is direct extraction from biomass. This approach relies on target chemicals already existing within the feedstock. Hence, the focus is extraction, followed by a separation of purification steps. Approach number two is what we are going to be focusing on today with biobutanol is production from biomass or biomass-derived compounds. In this approach, the target bio-based chemicals do not exist naturally in the feedstock, but are produced by it. The conversion can involve chemical, thermal, catalytic, and biological approaches, or even a combination of approaches. Biobutanol specifically is predominantly obtained through the production from biomass sources. This production is achieved generally via a microbial fermentation process using species of bacteria from the Clostridium genus. Now, let's get into a little bit more about the developmental status of biobutanol. The discovery of new oil fields, development of petroleum refining technology, and the invention of catalytic processes in the mid-20th century led to a shift from bio-based butanol to fossil fuel-derived butanol, as it became cheaper and more efficient to produce. But rising concerns over fossil fuel depletion, climate change, and the desire for energy security has sparked a renewed interest in bio-based butanol production. So far, biobutanol has started to make its way into the public domain as federal regulations begin to accommodate larger quantities of biobutanol mixture with gasoline. Notably, the two Clean Air Act provisions allow for blending of up to 12.5% biobutanol by volume with gasoline, and the U.S. Environmental Protection Agency, the EPA, allows a 16% blend of as the legal fuel equivalent of E10 or 10% ethanol. Um, Less pollution is generated with the use of biobutanol and with the allowance of greater percentages of biobutanol over its counterpart ethanol. It significantly reduces non-carbon cycling um, CO2 emissions. And so less pollution is generated with the use of biobutanol compared with petroleum-based fuels. Since the carbon dioxide captured by growing feedstocks reduces overall pollution by balancing out the carbon dioxide released from burned biobutanol, as you can see in this image. And a couple of these steps go into further detail, but I won't bore you with those minor details. Let's get into the nitty-gritty of this presentation, the economic impact of the biofuel. So, biobutanol's energy content is relatively high among gasoline alternatives. This is really, really important. Biobutanol's energy density is 10 to 20% lower than gasoline's, not great, but significantly better than its counterpart ethanol. Um, However, with significant funding towards bridging the energy density gap, it is likely to become more efficient with time. So that optimization of efficiency is a key note. This fact, coupled with the relatively feasible production cost, currently ranging from $1.5 per liter to $1.80 per liter, which translates to roughly around $5.68 per gallon for us Americans. However, very exciting new research also shows the potential cost of producing biobutanol being optimized to a very competitive 60 cents a liter, which translates to roughly $2.27 a gallon. Um, while that study is linked here for you to see, you can see on the right image where that 60 cents a liter comes from. Note that that research study was a analysis on the potential optimization of biobutanol and is not has not been replicated yet. So did want to add a little note there about that. Moving on, let's describe the efforts to communicate biofuel to the public. Um, while both the public and private sector have started to scratch the surface on communicating biofuel to the public, the demand for biofuel and the current stages of research and development make it unlikely that biofuels such as biobutanol make it into the market for several more years. Communication regarding biofuels remains in the realm of research inquisition and informative content, such as this, um, which really is just introducing what research is accomplishing in the field. The current situation for biobutanol as a fuel and for biofuel overall remains unpredictable. There is growing demand for renewable fuel, but only with competitive pricing compared to gas and diesel. If biofuel cannot match the cost of petroleum or gas, the combustion engine market may see a decrease in consumers as they switch to the more competitive electric vehicle. It is safe to say that there is a market for biofuels. That is for certain. But the window of opportunity is quickly closing. From my analysis, throughout the development of this project, it became clear the overwhelming potential for biobutanol to be successful on the market due to pre-existing infrastructure. But what this sector doesn't have is time. With the overwhelming growth in the electric automotive industry since 2020, biofuels are on the brink of being left in the dust. In order to combat this, the first and main step would be to acquire large-scale funding, securing investors. To date, most investors in biofuel research are private investors and invest in the only research available, independent research. Once large-scale group research has been instituted and research demonstrates the certainty of economic viability to the public, then development swiftly follows. Biofuel production has steadily increased over the course of the past 10 years, but not to a marketable scale. Due to restrictions in the ratio of biofuels to petroleum standards set by the EPA, um, if biofuels are shown capable of meeting combustion engine standards, which they theoretically have, that's still in the realm of research, not even in development. Then the limitations can be lifted and full-scale production can begin. So, while optimization models are currently being made, we really need to expand on that and take it from a theoretical stance to more of a practical application stance and begin to look into production line efficiency for actually producing um, to meet the needs of the American consumer. So, lastly, just to wrap up, biobutanol may still be in its research infancy, but its structural and logistical advantages are difficult to deny. Unlike other first generation biofuels, it fits directly into our existing infrastructure of pipeline and combustion engines without costly modifications. The fuel source doesn't significantly compromise cost or energy density, and with future optimization models, the future for this fuel looks pretty bright. Please note that all of my references for images and such can be found on this page. And again, my name is Kayla Graybill, bringing this presentation to you from the biology department at Texas A&M. So I hope you enjoy and you found something interesting, maybe learned a thing or two about biobutanol.